Hello and welcome back. We're now going to take a look at the second type of measure of spread, and specifically we're looking at quartiles and interquartile range. And I've just pulled the screen shade up a little bit so it lets you pause it and get some of the definitions down. So what is a quartile? Well, simply put, a quartile takes a large set of data and allows us to put it into four groups of equal size. So quartiles, we're dividing the data into four sets. All right, so what it looks like then in terms of a diagram here, we have our lowest data or lowest datum, and then our highest datum. So we're going to arrange the data in sorted order. Okay, in the middle, this is our median. It's also known as the location of quartile 2. And now, and that's something we've already done, now we're going to find the first quartile, Q1. So first quartile. And we're going to be looking for Q3, which is the third quartile. So this just indicates spots within the data. So there's an equal number of data points in the first quartile, second and third and fourth. So each quartile has the equal number of data points in there. Okay, so an interquartile range. Interquartile range is the range of the middle half of the data, and the larger the interquartile range, so the bigger the spread, the larger spread of the central half of the data. So formula for that, calculate the size of the interquartile range. It's simply Q3 take away Q1. So you're finding, and that comes out to be an actual numeric value. So you're finding how many data points, or what's the spread between the data point at Q3 and the spread at Q1. So I'll give you a range. And then finally, the semi-interquartile range. It's half of the interquartile range, and this indicates how clustered the data is to the median. In order to calculate it, you do the Q3 minus Q1 divided by 2, and that will give you the spread. So if we're talking about marks, what's the spread between median and the third quartile or first quartile? If we're talking about height, we're talking about the spread between the first quartile and the median. So we're just breaking the data into four equal groups. The group that exists between Q1 and Q3, that's our interquartile range. And if that range is very, very big, then our data is widely spread. If it's tight together, then we know we have clustered data around our median. And then similarly, our interquartile range is either the distance from Q2 to Q3, or it could also be the distance from Q1 to Q2. So there is our definitions. So quartiles then can be shown as a box whisker plot, so a box and whisker plot. So it's just a graph that illustrates the measures of spread of the quartiles. What's it look like? Well, it kind of looks like the face of a cat. That's where it comes from, that whisker look. And the only difference is it's a box instead of a cat and whisker. So what it looks like is you indicate on a scale. So if this represents our data points, so whether it's marks or height, we create a box once we find the median. So let's call that the location of Q2. We then find that Q3 is up here. So I have no numbers to work with. I'm just coming up with an example. What we would do is we create a box. And the box represents that half of our data is in that range. And then our whiskers come from drawing lines out from the box, reaching to the highest and lowest datum point. So we end up with a box. So again, the box and the whiskers. So our whiskers are the edges. So that's another way, or it's another illustration of the diagram up here. Okay? So it's just a visual aid, or another way to represent the data. So here's an example. Determine the quartile and interquartile range for the height of people in data management. So again, I've already entered the data into the QuatraPro or the spreadsheet software, and I'm going back to the previous example where we had to calculate standard deviation. So neat thing with software, with the spreadsheet software, I need this in, the height has to be in ascending order or descending order, one or the other. Ascending is the preferable. So how do I sort that yet keep the person's name with them? So what you do is you highlight name and height, and I'm going to go to Tools. I'm going to pick Sort, and each software program is a little bit different, but it's the same idea. And I'm going to tell it that I want to sort B2, or the column B. So column B has height. I want to sort it, but I want to maintain A. So the name's with the right heights. I hit sort, and we now see that my height is in ascending order, and the names stayed with it. Okay, all the other data remains the same. All right, so now I have it in the correct format. I'm going to bring it back. It's a little easier now to talk about it while it's in the Smartboard software. So again, bringing it back to this page. So now I have it sorted. Oops. Go back to a full page view, and here we go. Okay, so it's all sorted. So the quartile ranges. So when you add this up, there are 14 people in this class. So that means that the quartile range will be determined by that exact number. So I know I have 14 people. So I'm just going to do the rough work off to the side. That means that the median is between person 7 and 8. Okay, we cut this in half. It divides evenly. 14 divided by 2 is 7. So that means there's got to be 7 people above the median and 7 people below. So 1, 2, 3, 4, 5, 6, 7. So Shannon and Laura are on either sides of our median. So that's our Q2. So I'm going to write down over here, Q2 is equal to, I've got to take an average of the two. Now the nice thing here, they're both 170 over 2. So it's kind of a wasted step, but just to show you the process. If it worked out that there was 7.5, that means I need 7 below, 7 above, so there would have been one person. So for even number of data points, I can't stress this enough, even number of data points, take the average of the middle two. So there's our Q2. Q2 it occurs at 170. Now I have 7 pieces of data above and below the median. Okay. So now I need to find the midpoint of those 7. So repeating the process. Whoops, I got my smart pen on. So we'll just group that together for a second and move it over. So now I have 7 people. 7 people, so the median is, and here's the trick, if you add 1 to it, so 7 plus 1 divided by 2, that's 8 over 2, which is equal to 4. So it's the 4th person is the median. If I go back over here and apply it to this one, I looked at it a little bit different. If we did it the same process over here, I would have had 14 people plus 1 divided by 2 is 15 over 2, which gives me 7.5. So it tells me that it's the halfway point between the 7th and 8th person. I just used logic up here when I was doing it and said, okay, halfway is between, there's 7 above, 7 below. So it's whichever way, if you want to stick with the formula always works. Here though, now we're starting with an odd number, so that means there will be a person in the middle. So that means there's 7 people, the 4th person will be the middle of the data. So 1, 2, 3, 4, so Sammy is located in that middle. So that's our Q1. And you'll notice that there is 1, 2, 3 people above Sammy, 2, 3 people below Sammy. Similarly, on the other side, 1, 2, 3. So Kristen would be our Q3, 1, 2, 3. So now we have the data divided evenly, and we have 3 in each category, or the data spread evenly amongst them. So to finish this off, or to summarize, therefore, the value, and remember Q1 is a value, so Q1 will be Sammy's value, so that's 160 centimeters. Q2 we already found, that's 170, and Q3 is the value of Kristen, so 180. All right. So there we go. We identified the quartile and interquartile range for the students in this class. So the second part here, the bottom, says create a box whisker plot to illustrate your answer. So simply put, you just give yourself a line, and I'll put some values on it here. So I know that my Q2, so I'll cheat a little bit, it's at 170. So I'll go 180, 190, 200, 210, going the other direction, 160, 150, 140, 130, and hopefully that's far enough. So the box whisker doesn't have to be balanced. It might be unbalanced a little bit. So we know that we have, at 160, we have the value of Q1. We know at 170, we have our Q2. And we know at 180, we have our Q3. Close that up, and there's my box. Now, in this case, it's balanced because the difference here is 10, and the difference here is 10. So we're going to have a balanced box whisker graph. Now, max points at 205. So up here, it's Olivia. So 205, hers right there. So our whisker would extend out to 205. And the whisker in the smallest direction would be 150, which would be Claire. So it's down here. So there's the box whisker. You see the whiskers aren't balanced. All right. So we find that we have a greater spread in our upper quartile range, a greater spread in the upper quartile range. It means that we have fewer people up there, but once we get it up there, the height really increases. And if we looked at the actual people in that upper quartile range, it goes from 180 all the way up to 205, so that's a jump of 25, whereas in the third quartile range, it's only a jump of 10, as I said over here. So yeah, a jump, it is quite a jump. Now if we look in the bottom quartile range, okay, it's 150 to 160. So when we look at the actual diagram, the box whisker diagram, you'll see that this region is balanced or the exact same as this region because it has that same spread of 10. So it's all right. That's what it ends up looking like, and that's your box whisker, and that takes care of our second measure of spread. We'll finish up in the next video then.